Hey guys, Mr. Reese here to help you out on the next part of the 2.3 guided notes. So we are going to be looking at the applications of the product rule and the quotient rule. So one of the things that we do are with derivatives is figure out critical points, and we do that by finding horizontal tangent lines. Now, if you guys remember from before, a horizontal tangent line is when the derivative equals zero. So if we want to find out when the derivative equals zero, or when we have a horizontal tangent, we need to take the derivative of the expression and then set it equal to zero. So let's do this first one here. And it's going to be the same thing that we did back in section 2.2, but there's going to be a couple little things we have to add or watch out for when we have the quotient rule. So let's do the derivative. We got low d high, f prime of x. Low is x squared, d high is just 2. Minus high, 2x minus 1. D low is 2x. All over low, that'd be x to the fourth. All right, so we got 2x squared minus 4x squared plus 2x after we distribute here, all over x to the fourth. And that's going to become, let's see, that's a negative 2x squared plus 2x over x to the fourth. And so really we can simplify that a little bit. We can factor out an x from the top and cancel out 1 from the bottom then. And we get a negative 2x plus 2 over x cubed. Okay, so normally what we do, we want to find horizontal tangents. We're going to take that derivative. Oh, why did I put a 3 there? Good morning. Try that again. Normally what we do is we take the derivative and set it equal to 0. Now the one thing that we have to do here is we have to make a rule because we have a fraction, or we have to understand a rule here, is that this fraction can never have the denominator equal to 0. So we need to make sure we say like x cubed cannot equal 0, or in other words, that x cannot equal 0. That's just going to be a note that we would stay here, because x equals 0 would actually be a discontinuous point if we go back. And so if we did take the derivative and we got x to equal 0 at the top, we'd actually say that doesn't work out because it gets factors from the bottom. And in fact, if we'd never simplified this, we would actually see it on x equals 0. But we simplified it, that usually normally goes away. So really what we need to do is to just see, okay, at the top here, when does negative 2x plus 2 equal 0? Well, that's when negative 2x would equal negative 2, and that's when x would equal 1. All right, so where on the graph would we have a horizontal tangent line? We would have it at x equal to 1. We just make sure we'd also say like, okay, x cannot equal 0, but that's where we would have it. All right, so let's practice that again. Let's look at another one. We got x squared over x minus 1. Okay, so let's first take the derivative, low d high, high d low, g prime of x. Low is x minus 1, d high is 2x. Minus high is x squared, d low is just 1, all over low, which we'll leave as x minus 1 squared. All right, so let's distribute the top here. We got 2x squared minus 2x minus x squared over low. And simplify that, that is just an x squared minus 2x over x minus 1 squared. Okay, so we took the derivative. We're going to take that expression, set it equal to 0 to find horizontal tangents. So the one thing we want to do at the bottom here is make sure that we say like x minus 1 squared cannot equal 0 because it's a fraction. We can never have 0 on the denominator. And if we solve for that, it's basically saying that x cannot equal 1. So when we solve the top part now, if we ever get 1 as an answer, we got to cancel it out. But let's now solve the top part. When does x squared minus 2x equal to 0? Well, to solve this quadratic, we have to factor out an x and then set both parts equal to 0. Well, x equals 0 is just a simple expression, and then x minus 2 equals 0. That means when x would equal 2. So we have 2 times here when we would have horizontal tangents. One would be at 0, and one would be at 2. And we can check this out by plugging this into Desmos and looking at the graph. Okay, next we're going to do a couple different things here just to kind of practice our skills, making sure we understand the quotient rule and the product rule. So if you guys remember, we would look at graphs and we would determine like, okay, what's f prime of x or what's going on We're going to do the same thing here, but we have P prime of 1 and Q prime of 4. And we have the graph F and G. So if P of X is F of X times G of X, that means, oh, I started writing F of X. Let's clear that out. Well, we'll use an eraser here. That means P prime of X would be the product rule. It'd be F prime of X times G of X plus F of X times G prime of X. So if I'm finding P prime of 1, I need to find F prime of 1, G of 1, plus F of 1 times G prime of 1. So let's look here. We're going to 1. I'm just going to circle dots here of both of these. So if we say slope F prime of 1, that's saying what is the slope of F at 1? If we look here, this line is going up 1 over 1, so the slope is 1. Next, G of 1 is not slope because it's not G prime. It's just where is G at 1? G is over at right here. That's at 4. All right, now next one, F prime, or not F prime, but F of 1. F of 1 is saying where is F located at 1? F is located up at 6. G prime of 1 is what's the slope at 1, or slope of G at 1. If we look at G here at 1, it's going down 1 over 2, so that is negative 1/2. So all we need to do is figure this out. This would be 4, and then minus 3, so the answer here would just be 1. Okay, let's do the next one here, but we're finding Q prime of 4, and if we look, Q is F of X divided by G of X, so that's the quotient rule. We got low, which is G of X, low, D high, F prime of X, minus high, F of X, D low, G prime of X, all over low, low, G of X squared. So all we're going to do is plug in 4 into all these locations, and we're going to have a lot of values to find that we will just plug into the formula and simplify. Oh, I started writing X's because I was just looking at them. Okay, so we're going to go over to 4. I'm going to circle these spots here, see what we got. All right, so G of 4. Where's G located at 4? It is located up here at, is that 3? Yeah, that's 3. Times F prime of 4. What's the slope of F at 4? The slope of F here is down 1 over 1. So that's negative 1. Minus F of 4. What's the value of F at 4? That's at 7. What's the slope of G at 4? The slope of G at 4, that's a flat line, that is 0. All over G of 4, it's located here at 3, and then squared. Okay, so if we simplify, this would be negative 3 minus 0 over 3 squared is 9. Now what does that simplify? That's just negative 3 over 9, or negative 1/3. There's the values. Okay, so I think it'd be good to kind of look at the CYU just to make sure you guys understand what you need to do on today's work here. Put on my drawings. Let's open up that document here. So first problem here, just like the ones we did, okay, we'll find the horizontal tangent. So take the derivative, set them equal to 0. Next, these look pretty familiar problems, especially 81. So you guys should be all right with that. Just watch the video again, kind of go back. Okay. So it's been a minute. You probably had a weekend, go through. Second derivative. So remember, all you got to do is take the first derivative, take it again to get the second one. Only thing, it gets a little confusing on 96. So make sure you guys have any questions. You reach out for that one and let me know. All right, let's take a look at these problems here. It's been a while since we've had to sketch graphs, and all we're doing is sketching the first derivative and then also sketching the second derivative. So if we want to take, I don't know, we'll do number 111 here and find the first derivative. Remember, all we were doing first is to look for horizontal tangent. So right here on the graph is where the function has a horizontal tangent. So I'm going to put a 0 down right there on the x-axis. Now the graph is going up and then it becomes flat and then goes down. So our answers need to be positive. They need to be above the x-axis, and then going straight down to the negative, into the negatives, because we have negative slopes. So here is the first derivative. Here's f prime of x. All right, all we need to do now is to get the second derivative, we take the derivative of this. But if we look at this function, there is no critical points. There's no spot here where we'd have a horizontal tangent. This slope is just a constant slope going down. So this is a slope that's always negative. So we need to have a value that's always negative. And so here would be our f double prime of x. Now, if you ever want to just kind of make up problems just to kind of help you out here, that might work. So you might look at this equation and say, you know, that equation, the original one looks like a negative x squared, and then it shifted up something like 6. Negative x squared plus 6. Well, what's the derivative of that? The derivative of negative x squared plus 6 is just negative 2x. All right, which is, that's what it looks like, right? This is just a straight line. Now, it's probably shifted down a little bit because this isn't, exactly squared. It might be a negative 6x plus 6 or something like that, or minus 6 or something. We don't know exactly what the equation is, but we know we're going to have a negative line. And then if we take the derivative of that, the derivative of negative 2x is just negative 2, which is a flat horizontal line in the negative. So you can make up problems here to kind of see what the derivative should look like. So if you look at this problem here, all right, this is like an x cubed, right? Well, the derivative of that would be an x squared. So you should have a parabola for the first derivative. And what's the derivative of x squared? 2x. So you should have a positive slope for the second derivative. All right, that should help you guys up. That should wrap up this section. We got one more to go before we get to the end of this huge 2.3 section. And it's going to be its own test. So you guys have a great day. I will see you next time.